So this is REPLs all the way up. We have a groundbreaking idea for you for software development. What if we used feedback loops and iteration? Okay, maybe that's not such a groundbreaking idea. About once every 5 years, somebody rediscovers that agile was about feedback loops and iteration. As it turns out, even the original infamous waterfall paper by Winston Royce back in 1970 was actually saying that pure waterfall is bad and what we really need is iteration.
At least a little bit. He admitted that a little bit of iteration is necessary.
So feedback loops, we like them, right? This is not controversial. We think they're a good thing to have in software development. But when we talk about feedback loops, there's a few different kinds that we talk about. So
yeah, once we agree that feedback loops are useful, we can talk about, okay, which ones are useful and how can we make them more useful. In this talk, one kind of feedback loop is a cybernetic control loop.
Cybernetic?
Cybernetic, yes, from back in the day. The canonical example is the thermostat. It's like, I'm going to take action by turning on the heater, and then I'm going to read the temperature of the room with the measurement to find out what action I should take next in order to keep a consistent temperature in the room. That's not what we're talking about. This kind of loop is kind of like...
we could use one of those
Would
in
you
this room.
click? Would you
We
click?
could use one of those.
Oh, yeah,
in
that's
this
true.
room.
We could. Yeah, I'm freezing. Would you click?
Yeah.
Thank you. This is like our CI tests. Our CI tests are this kind of control loop of I'm going to keep the build not broken or else you're not going to production. So these are checks. These are like yes, no, red, green experiments to validate our assumptions. And those are boring.
And they're usually there to kind of impede change, to keep things from changing.
Yeah, true. And we want to change things and make them more interesting.
What we're more interested in today are exploratory loops.
So like when CI does fail, you typically are like, oh, well, I need to do something. You want to duplicate the failure locally in your local tests where you don't have to wait 40 minutes to find out the results, and you can run it, and then you can iterate on it, and you can change something, and you can find out what happens again. So I don't even typically go look at the error message in CI. I want to find out what happens locally, and I go try to duplicate it there. Well, I might look at it to see that I'm duplicating it. But the point is, bring it closer and get it somewhere where I can do more than experiment, I can explore.
Yeah. So that's what we're talking about. We're talking about exploratory loops, and I think we can all agree they're a good idea, but not all exploratory loops are created equal. Some are better than others, and I feel like this is something we don't talk about as much is what is a good exploratory loop look like? Except that's not actually the best question because it turns out that human cognition is based on touch rather than vision.
Yeah, we like to think that seeing is knowing, but really feeling is knowing. The babies have it right when they put things in their mouths.
Yeah, in their mouths. So really the question we want to ask is, what do good exploratory loops feel like?
Because we can't put them in our mouths.
So to answer that question, let's start with a tiny bit of history. Once upon a time, back in the 1950s, if you wanted to run your program, you had to punch it on a stack of cards, and you had to put that stack of cards in your briefcase, and then you would get on a train, and you would take it to a computing center somewhere like Cambridge, and you would wait your turn, and you would feed your cards into the computer, and it would run your program, and you would get a result, and the result was probably an error. And so you would pack up your cards into your briefcase, and you would get back on the train, and you would spend the next 2 weeks deciding how you were going to change your program to try it next time.
Think about what you did.
I think that we can agree that this was not a very nice exploratory loop. But technology moved on quickly, and by 1964, we had the brand new PDP-1 computer, and the Lisp programming language was implemented on this computer. I know we have at least one Lisp programmer in the crowd. Anyone else? Nice, okay. Yeah. So Lisp was implemented on here, and as part of the Lisp implementation, there was this amazing feature where you could type some Lisp code into the teletype, and as soon as you were done typing that expression, the PDP-1 would take over, and it would type out the result of that expression right there on the same piece of paper. Cool. And this this was the very first Read-Eval-Print-Loop, or REPL. And I don't have access to a PDP-1, but here's that code from that original Lisp manual running on a modern Lisp implementation. So this was a REPL, and this felt good. This was a really nice experience.
You could try something, see what happens, turn it around, see what it looks like from that direction.
It was almost like feeling your way through the problem. So this was great. But you had to still go to a place that had a PDP-1, which, you know, there was like one of those places.
Trains were still involved.
Yes. But technology moved along quickly. And by the late 1960s, early 1970s, at Dartmouth College, they created what was called the Dartmouth time-sharing system. And the great innovation here was that you didn't have to be in front of the computer. All of these teletype terminals were connected over phone lines to the DTSS, dozens and then hundreds of them, and then other colleges were phone lining in, and you could communicate, and it was the time-sharing system, meaning that multiple people could run their programs at once. And so imagine you're a student in this era. You sit down in front of one of these teletypes, one of these Burroughs teletypes. Maybe you have this manual sitting in front of you. This is My Computer Likes Me When I Speak in Basic. It's this wonderful little pamphlet by Bob Albrecht.
There's seriously like 24 different fonts in this book. It's wonderful.
1972, incidentally, this is by the same person who gave us Dr. Dobbs' Journal of
Computer Calisthenics
and Orthodontia.
History.
So you would sit down, you would start following the instructions in this tutorial, and you would type in a little bit of basic code into the teletype, and then you would type run, and within about a second, you would get the result of your basic program. And this wasn't quite a, we lost a slide. Oh well. This wasn't quite a REPL because you had to type run, but it was really close. And it was a really good experience. And it was such a good experience. It was so invitational and so welcoming that 80% of the student body at Dartmouth were using this system. And we're not talking about the computer science students, we're talking about all of them. So this was just like, it felt good.
It was the ChatGPT of its day. Everybody was trying it.
The time moved, time went by. The computer, the PC revolution happened and ushered in a new dark age of computing. But there were still bright lights here and there, including over at Xerox PARC, Alan Kay and Dan Ingalls were creating the Smalltalk system. Is anybody here programmed in Smalltalk? Oof.
No.
Okay. Well, I can tell you that Smalltalk was one of the most interactive and dynamic programming systems ever developed. It was like the runtime is the IDE, is the runtime. You could edit and modify any of the code in the system at any time.
It was the hottest of hot reloads.
It was the hottest of hot reloads. It was the REPLest REPL that has ever REPLed. It was an incredible experience. But it never really took off. And then, in the 1980s and onwards, we kind of had the C language family pretty much took over. And
because as Kent Beck put it, even people who had seen this, they're like, I want Vim, I want my code in files. Spoil sports.
Yeah, ruined it for all of us. And so compile times increased, integration times increased to the minutes and then to the hours and then to the tens of hours, and suddenly we were getting back into that train situation, and this did not feel very good.
Yeah. But people got to
did
play video games during compiles.
It did give us a lot of chance to, have sword fights on office chairs while we were waiting for the compile. So, we did what we could. Some of us used debugger-driven development, where we just spent all of our time in the debugger because the debugger gave us basically the closest thing we could have to...
But then how much of that time did you spend actually setting up, getting to the breakpoint that you needed?
Mm-hmm. But, once you got in there, you could actually see what was going on, and you had something close to a REPL, sort of. You could try out some statements there. We did what we could. Now, in 2000,
Okay, so then we get to test-driven development or test-driven design, depending on who you ask. And here, actually the first unit test framework, Kent Beck and Ward Cunningham wrote it in a small talk REPL-y thing. It started in a REPL with a little bit of additional automation for checking assertions, for automating the checking of assertions in addition to the running of the code. And the beauty of test-driven design when you start with a test is that you're exploring the interface that the code you're about to write might have. You're exploring what you might send in and what you might get back. And then it's red, because the test is red because it's failing. And then you go implement the code, and then the test becomes green. Sometimes you go back and change the test in there while you're at it. And then you're able to use that check. The test at that point becomes a check to refactor the code and make it prettier. And then, as a bonus, you get the artifact of the unit tests that you can then use as a check in CI in the future.
In a control loop.
But the initial part of writing the test in an exploratory fashion, that's where test-driven design really gets its punch. If you're writing the tests afterward, you're missing that part. All you're getting is the check. You're missing the exploration. So in Java, it's kind of a lot of work to try something, but, well, okay, now Java has a REPL, but it didn't when I used it. Has anyone used the Java REPL? 3 more people than have used Smalltalk. Okay. But JUnit gave us a place where we could try things because we had a setup, and that was progress. It was an attempt to get back to that exploratory feel.
Right. We were trying to get back there. It gave us a taste of that. Another thing that happened in that era was we kind of had this sudden explosion of so-called scripting languages. We had, your Perls and your Pythons and your PHPs and your Rubies. And what was interesting about these, and one of the things that made them so attractive, was that they all came with a REPL. And as a matter of fact, if you opened up, the initial tutorial for any of these, the first thing it would tell you is open up this REPL program and start typing in these expressions that we're teaching you, and you could see the results of those expressions as soon as you type them in.
It didn't make you create a class and public static void main.
And this, yes, public static void main. And so this was like one of the huge draws. I kind of came of age while these were becoming popular, and that was one of the huge draws, was these REPLs. And so here is an example of coding in a scripting language in Ruby in a modern REPL. And what I was doing here is I was trying to explore the space of how do I quickly get a whole bunch of fake accounts into the system that I'm building and so I'm like exploring both the database API that I need to use to get them in, as well as like a faker API for creating fake data. And it's just this really like interactive process. Sometimes, something goes wrong, but usually the error is also instructive. It gives me some hints about what else I could try.
Yeah, you get to new errors as fast as you can, which is most of my goal as a programmer.
Yeah, that's exploration, is getting to those new errors. So, it feels like over the history of programming, there's this state of grace that we keep trying to get back to. And we keep trying to get there because it's approachable. It's satisfying. It feels good. And it's productive.
Yes, yes. So we can take this feeling and being like, all right, this is an indication in our, as humans, we have a system sense, and we can sense that this kind of exploratory loop is good for us.
Yeah.
So can we break that down?
Well, and one of the reasons that it feels so good is because this is how we think. This is how we evolved to think. There's this notion that we have ideas sort of in a vacuum, and then we write them out onto paper once they're done. But actually, the way we think is externalized. We pick up a stick, we scribble on the ground a little bit, we look at it for a second, and we wipe some of it out, and we scribble some more. That's how people think.
Hammock time is an exception.
As Edith Ackerman says, using objects to think with. Or as my old family friend Kit Martin, who tragically passed away from cancer just a few days ago, said, knowledge fluidly grows through action taken in a complex system.
And you can feel this, like I felt this, I sensed this as a developer. Whenever I approach a new piece of code and I want to be able to, I want to figure it out, I have to figure it out by changing it. I'm going to refactor it, or I'm going to break it. There's this like coder symbiosis that develops as we change the code. We think with it and we become part of it somehow. I don't know, it's a weird feeling, but I really like it.
So we submit to you that maybe REPLs are kind of a gold standard of a good exploratory feedback loop in the small, in like the smallest unit of programming that we normally think of.
Which is a line of code.
A line of code. And the question is, can we have this feeling at larger scopes of our work? So in order to explore that, let's dig in a little bit deeper into what makes the REPL feel so good.
One letter at a time.
One letter at a time, starting with read. So a REPL reads. When you sit down in front of a REPL, what do you see? You see a prompt. It is invitational. It's approachable. It wants you to type something in there. And what can you type in there? Anything.
Which can be intimidating at first.
A little intimidating. But it's open-ended. These are not boxes to fill in. These are not drop-downs. You've got a wide open space to try stuff. And like most, you can type in anything you want. Most of what you will type will be an error. But the error will be instructive. It will probably tell you something.
Also, I mean, unless you're pairing, I guess, nobody else is even going to see it.
Yeah.
It's your error, just for you. Take it home on the train with you.
Most REPLs these days, also provide some kind of like autocomplete or suggestion mechanism. So they're very discoverable. You can like a lot of times there's like serendipity where I'm paging through the autocomplete suggestions and I discover a method that I didn't realize I needed. So
yeah, it's kind of interesting. It's not a wizard. It's not a window with a bunch of buttons, and yet it's discoverable. And it's highly incremental.
It is very incremental. So you don't have this pressure to get it right the first time, because you can always hit the up arrow. You type some crappy code in and execute it, and you get an error, and you up arrow, and you fix it a little bit, and you execute it again. It's very incremental. And what you get from all this is you get this sense of safety. What happens in the REPL, like you were saying.
Stays in the REPL until you cut and paste it out, of course, but that's your choice.
Like you were saying, it's your own private error.
Yeah.
You can do the dumbest stuff in the REPL, stuff that you might be embarrassed.
And it feels like play because you know this isn't production.
Yeah.
It's not even a file.
You're not going to check this in
before running it.
There's no record.
Well, the REPL has a record.
It has a record, but it's ephemeral.
Yeah, exactly. It's ephemeral. It's lossy.
So we read, then we eval. We evaluate the code.
Well, but we don't eval it.
Well, yes.
The REPL evals it for us. We don't have to do anything except press enter.
Yeah.
And enough right parentheses.
There's no, it's taking the language that you're familiar with. It's concrete. It's not. There's no special abstraction for play here. These are not Duplo blocks. These are the exact same Legos that you program with, which means that anything you come up with in that REPL, you can transfer directly to your actual code.
So you're learning about your programming language. You're learning about the API of whatever you're using. This is both single loop and double loop learning, which we'll get to more of in a minute. But you're both, does this work, and what else can I do? What can I learn about my language? Because you're working directly in it.
Yeah.
And that way, you can learn as quickly as possible by poking it.
By poking it. This is one of my favorite things about REPLs, because another thing about how we learn is, we don't, like Kit Martin was saying, interaction with a complex system. Not taking in a complex system, not pure consumption. That's not how we learn. We learn by poking things with a stick and seeing what falls out. A lot of times, who here has learned more about a system by deliberately breaking some code to see if it hit that point and threw an exception?
Yeah, a lot of people. In JavaScript,
right?
I like
REPLs,
to throw poo.
Yeah, or raise hell in Ruby. Yeah, REPLs are great for this kind of thing. Insert
Yeah.
some crappy data, see what kind of errors fall out.
Yes. And they're just automated enough.
Yes. So this is really important. You can open up a file and write some code and save the file and go to your shell and run the file and then open the file again and edit it and save it and run it. You can do that, and I have watched, I do a lot of like pair programming with random people. I've watched a lot of programmers do this. The REPL says, we know that's what you're going to do next.
We know you want to, yes, save this command, execute
We know you
it,
want to run this
and get the
as soon as
results.
you've saved it.
Yeah.
So let's just do that. And this is a really important property, we think, because we're automating, we're taking as much friction out of the part that repeats as we possibly can, the part that's undifferentiated, but we are leaving the rest as open as possible.
Exactly.
Okay, so that's read and eval. Then, after you
more.
poke the system with a stick.
No, 2 more. Print. Okay, print.
After you poke
After
the
you poke
system with a stick,
it
something
probably
comes
gives
out.
you an error. And then you get to read the error because the output is rich.
It is rich. So we call it multi-channel.
There it is. You get standard out, you get standard error, everything that happens, here it is, your problem now.
And it's not just the result of what you just typed in. You know, it's not just the result of that expression. You get to see, standard error or log statements along the way, and a lot of times these tell you a lot about what's happening. Like, oh, there's a database write that got outputted to the log, so now I know that that does a database write.
Yep.
And the output is arbitrary length. It can be as long as you want. Sometimes that's way too much. But the wonderful thing about this is it lets you do the thing where you like
Up arrow, add a dot. On the shell, up arrow, pipe it to cut or grep. Yeah, so
you can start with like, you can dump a whole table and then like browse through a little bit,
Yeah.
and it gives you some hints for how to narrow.
okay.
And you've got that whole story behind you. You can always reference back. It's an ephemeral story, but you've got that, it's not clearing the screen every time. You can always go back and see the story of how we got there, and if you need to, you can capture that and put it into a documentation,
Yeah,
document,
put it in
into
a
your
variable, put it in a function, repeat that.
Yeah.
You get to build up to some degree.
code. Yeah, you're building up, you're building a story, it's narrative. And when you evaluate some code, the output, the result that you get, if you're looking at a data structure, it's exposed ductwork, okay? This is not a nice packaged,
This is
two
not
string.
a report with tabs and the date at the top. In Ruby, it's inspect instead of two-string.
Right, exactly. It's an inspect. And so what you're seeing is a nice, you're seeing a basic serialization of the data. And a lot of times what this gives you is it gives you little threads to pull on. It gives you little clues about where you might want to go
And
next.
that's the exploratory bit.
And that's also an example of you get surprises. You get things you didn't expect.
You might even read the error message because it is right there.
So these things are kind of experimental. And Jess, you know a lot more about me than the philosophy and history of science.
Okay, I do read philosophy of science for fun.
You do. Would you call this science?
Okay, so here's the thing about science. My favorite thing about majoring in physics was learning about the scientific method. Okay, you have a hypothesis and then you try to falsify it. And this was Karl Popper's definition of science back when he was like 20 in the 30s, is that there's a theory, it's a scientific theory, if we could reason from it to what should happen and then try to falsify that. And we do that when we try stuff in the REPL or when we run our unit tests. We're like, I think this is going to work. Does it? And if I try to do this, especially when I have a pair, I think what's going to happen next is it gives us what we want. Or I think this is going to fail and give us an error. And then you're creating a hypothesis, and you might be able to falsify it. That's the experimental part. That's the single loop learning of, does this work, or should I go back? But science doesn't really advance this way. I mean, okay, this is like a nice abstraction to think about, but there we're talking about like controlled, programmable, repeatable experiments, which you can totally do in your unit tests. We can do these in programming, which is very nice. But science really advances with the everything else, with the surprise, with what happened that I didn't expect, with, I'm trying to grow these bacteria, and in this one Petri dish, they're not growing. And then you pay attention to that, and then you get penicillin. It's the stuff we didn't expect that is the double loop learning, is the change our model of how the language works, or how the API works, or how our software fits together. That's the value. So even while we need to do the experiments, we also need to look for surprise.
Yeah, so
the
next
REPL
time,
gives us both.
So next time somebody says we should make our development process more scientific, great. Let's have more surprises.
Excellent.
And we like to call this explorimental.
This is not a real word, but it's a word today.
Okay, read, eval, print, and finally you loop.
Loop, loop, loop. Because when you get that error message, it's time to get another one. You get to try again.
Try again. Oh, by the way, in case it wasn't obvious, we pulled a bunch of illustrations from that book.
Yeah, it has cute drawings as well as cute programs.
One of the things we like about REPLs is that they have what I think of as infinite depth. You've seen those TV shows where they're like, zoom in, enhance.
Computer, enhance.
You can actually kind of do that in a REPL because there isn't like an artificial floor to what you're dealing with. You are not in some sort of, you're not in the kiddie pool here, you know?
It was not pre-aggregated.
Yeah, exactly. It's not pre-aggregated. You can keep pulling threads. You can keep digging down as far as you need to go. And then we were talking about this a little before, but REPLs give you this incremental ability to build up context over time.
Yeah, because you can use words like explorimental and be like, okay, var explorimental equals this thing, and then you can use that word again, just like in a conversation.
And you know what's important to me about this is that they're stateful. In a REPL, in a given REPL session, you have state that you're building up. You can
And
even
it's private state.
Right.
It's just you and the REPL, so you have the safety, but you're having an ongoing dialogue.
you don't have to come up with the whole expression that does the whole thing that you're trying to play with all at once. You can build up to it slowly.
This is not an essay that you're turning into your English teacher.
Exactly.
But it's not, it doesn't have perfect memory. Or the REPL has just fine memory. But the thing is that unless you cut and paste out of it, that work is gone. And that's okay. It's part of the privacy. It's part of the learning again. Whenever I lose code, I'm always like, okay, I can write it faster the second time. It's going to be fine. I can learn this again.
And better.
Yeah, and that's also a form of freedom because we're not tied to this.
Yeah. And REPLs are fast, right? We like that they're fast.
Yeah, they return in like a second or something.
Except that's actually not exactly what we like about them.
It's
really
not all about
It's not all about must go faster here.
Okay, because there's some feedback loops that are too fast. Canonical example, hotel showers. You're trying to figure out how to work the shower. You don't know where the right temperature setting is. So you're like, oh, it's cold. Turn it up. Nope, still cold. Turn it up. Nope, still cold. Hot! Okay, because you're responding to the temperature of the water before your action has had its effect. So you gotta, I do this from outside the shower, turn it way hot. Determine the correct pace by finding out how long it takes to change temperature. And then I can adjust it with an appropriately paced feedback loop. You get this problem with A/B tests, right?
Yeah, I remember like when A/B tests were first like the new hotness, and it felt like everybody needed to be doing A/B tests all the time, even if you had 10 users. And so, like, you could do, 100 A/B tests and get
see a
whole
difference.
lot of answers.
But were any of them relevant? Really hard to know. That takes a lot more time. When you're talking about a loop that involves humans, it's not gonna be super quick.
So really, what we like about them is that they move at the speed of your questions. And at different scopes, that means different things. At the REPL, one line of code,
It has an effect. Here it is.
Back, under a second. At other scopes, not so much.
Yeah.
It's an appropriate speed.
Is that everything?
And
Yes.
REPLs are
Conversation.
conversational.
Yes, the loop makes it a conversation, not a command.
It's like, I mean, this is another of the ways that we think. We think in
think in
conversation.
dialogue.
We think in dialogue, yeah.
Yeah, and dialogue doesn't imply two people. I don't know why there's the die suffix, but in dialogue with one or more people or the world, where the computer
Or
is
the
the
system,
world.
yeah.
Yeah, that's really how we get stuff into our brains.
So these are some of the things that we think make up REPL nature, what makes REPLs feel so good. They're safe.
So how can we get this in
Auto-manual.
larger systems?
Yeah. Explorimental and conversational. How do we get this at wider? Can we get this?
We make up
wider
more
scopes?
words.
Can
No,
we
just
use
kidding.
this?
I think that's all the words we make up.
Can we use this feeling as a guide to what are good feedback loops at larger scopes? So we know at the scope of a line of code, REPLs are great. Let's move up. A unit, as in unit test.
We've talked about test-driven design already. So yes, unit tests are a way to explore a unit. It's bigger than a line of code. And also we like that we happen to get the artifacts for making checks later.
Yeah.
That's great.
So, test-driven design.
But here's the thing. If you run your tests and you don't look at the error messages, then they're not experimental at all. But if you actually do go look at the error messages, then you might learn something. One thing I like to do with unit tests is make them super expressive about what failed and why. And when they're green, that can feel like a lot of work. But when they're red, is the correct time and the motivating time to make them speak to me about the error so that I can learn more from them. So read your error messages. They have a lot more to say, especially these days, like the modern languages, like Elixir and Rust. They consider it, if you get an error and you don't know how to fix it, that's a compiler bug. So error messages are getting better. Keep up with that, make your error messages better, and read what you get.
Yeah.
I learned that lesson over and over and over and over and over.
So moving up in scope, a feature. What can we do here? Okay, so one thing that we can do is we can avoid being Sherlock Holmes. I am a giant Sherlock Holmes fan. And if you've read any Sherlock Holmes, you know that he was the world's greatest consulting detective, and a lot of times he could solve a problem just by people would bring him information about the problem, and he would steeple his fingers and think about it for a while, and then he would come up with a solution to the case without even going and looking at it. And there were two reasons that he was able to do this. One, he was the world's greatest consulting detective, and two, he was fictional.
Okay, but some of you may have a Sherlock Holmes at work, sometimes called Brent or Purple Developer, who can glance at just the shape of the log output over here and go over here and find just the one log message and correlate with a spike in a graph that's all spikes and tell you what the problem is. Okay, this kind of effortful deduction is not what we want. That takes an incredible amount of expertise in the system, and we don't have it, and we're not going to have it as soon as the system changes some more. What we want is for the system to make this easier for us.
Yes.
We want something more like a REPL that makes it easier to learn. So if you feel incredibly clever and smart as you're writing code or as you're fixing something, that's a bad sign.
And a lot of times what it's signaling is that there is friction to using tools that actually tell you what's going on.
Yeah.
Either it's hard to get into them, or you don't know enough about them, or there's a lot of forms of friction. But some of the tools that you can use instead of switching into Sherlock Holmes mode include tracing. Tracing has a long, long history, way back into the
This is like
depths.
the OG of tracing.
The OG tracing. So this is actually a fake trace from that book over there. The general idea of tracing is telling the true story of what your program actually did.
It's like skipping to the end of the Sherlock Holmes book and reading the confession.
And this exists. All programming languages have their own form of tracing. It also exists in your operating system. Running behind me is an example of using the strace utility in Linux to figure out what are all the files that a particular program is reading from. And this is a very kind of REPL-y process, even though it's at the shell.
This is called the documentation is not up to date. No, really, where do you get your config? And it takes some refinements. You've got to like S-trace, okay, what do I want? I want open, no, I want open at. But the REPL, or the shell is a REPL.
It is.
So we can iterate on our tracing and find out what really happens in a program.
Yeah.
And that's a stronger feedback loop than mysterious logs.
Yeah. Building on top of tracing, we have debuggers.
Debuggers, which
you
often
know,
contain a REPL.
Which often contain a REPL. They can, they can tell you what's really going on.
But sometimes it can be a real pain to use a debugger because there's steps to set up. So we'll automate those, but
yeah. So we sometimes want to approach from a different angle. A lot of times that says you need finer-grained unit tests.
True. True. So yes, debuggers are helpful. Use them when they're helpful. But if you find yourself using them all the time, you might want to
step back a little bit.
Build yourself a better loop.
Yeah. See if you can work at a smaller scale for the kinds of things that you're looking at.
Throw better exceptions.
Reload-driven development. You edit a line of code, you reload the browser. You edit a line of code, you reload the browser.
Yes, do that.
Do
Great.
it. It's not shameful.
It's the only way to have a dialogue with CSS.
If you have the ability to do this, absolutely do it. If you have the power to, choose systems that let you do reload-driven development.
That let you hot reload a module.
Yeah, one of the things that makes this better is the ability to hot reload. Some frameworks have hot reload built in.
Is that Flutter?
Yeah, this is Flutter, which has
Android.
hot reload. Save the code, and it's automatically reflected without restarting the app.
On your fake device.
On your fake device.
That's cool.
Or your real device. It actually works. The hot reload works on your real device, too. Wow. So, yeah, use it. OK, moving up.
Yeah.
To the level
that's
of a
an example of
service.
the creators of Flutter have enabled this kind of feedback loop for us as a part of our developer experience.
Yeah.
OK, so moving up.
Moving up, services, developing on services.
Oh, services are more than just code. They typically have a database involved to save state. So yeah, learn SQL. SQL is a REPL. There's a command line. There's like prettier versions of the REPL that will help you write the command, but at its heart, it's a command line. You can see the code. I feel like fortunate to have grown up in the era where developers actually learned and wrote SQL before ORMs came in and muddied everything. But even now, I use SQL at work all the time. It's amazing how much this helps. And when I'm talking to like new developers who are studying, they're like, what should I learn? I'm like, JavaScript and SQL. It's really great.
Yeah.
You can explore your data.
Yeah. We work on a lot of different projects. Neither of us ever develops on the bare metal anymore. The first thing we do when we start into a new project is we look to see if it has a development container already, and if not, we create a development container for it. And then once we've finished creating a development container for it, we have a reproducible environment that we can then give to other people.
And then they can fix it so it works for them too.
And they can fix it, they make it better. But
this is auto manual.
This is auto manual.
We want, especially in open source, we want people to be able to run this code and make changes to it. That involves a lot of setup. We're going to automate that part so that they can jump in and do whatever open-ended change they want to make.
Yeah, and a lot of people think that this is just for onboarding new team members,
Does
new developers. But what I've seen this enable also in organizations is people who work on a completely different service and just need to understand how it interacts with yours. They get up and running on your service really fast, and they can start contributing like
also,
tiny fixes
when your
back.
computer is stolen. And
Or the front end people can like bring up the back end now.
Yeah.
It's really powerful, and this is an example of automate the heck out of the things you know you're going to repeat.
Okay, and then a service is only part of an application. So once we get multiple services involved, then what do we need?
Then what do we need? Well, first, we're probably going to be doing design work, right?
So this is a dialogue with other humans. Turns out many of them do know something. And you can find some surprises when you start all putting what you know on the whiteboard. That's useful.
This is that externalized cognition, and it's so powerful with people in the room where you can see, oh, this is how our understandings of the problem don't mesh, and there's so much good surprise there.
Yeah, you need like when you work with people, it helps to have something physical to share together. Whether that's, these days it's often a shared Google Doc that we all have open during the meeting, or it could be a Miro board, or something like that. Or we both have the code open, and we have like a shared VS Code space, or we're sharing screen. That really helps get together around some sort of shared truth.
Yeah.
Even if it's just Post-its.
Yeah, yeah, so powerful. Oh yeah, this one's
here's some more automation. Okay, so this is the part that applies to the debugger, but also automate the setup of getting yourself to the place where you can test things. Inside unit tests, I love generators from property-based tests or fuzz testing. Even if I never get around to writing a property or doing the thing where I make it automatically generate stuff, I use the generators all the time to be like, okay, give me a user, make sure they have some documents, and make one of those documents be deleted. Whatever it is, I can pull something out of the automation and then modify it however I need. Okay, this one's deleted. And then run the test. Automating the setup of this in integration tests or testing in production, automate the creation of a test user, because you just need that all the time. And once you have it, it's like you can skip the many, many steps to get to the breakpoint and just go to test what you need to. So this is different from automating your end-to-end tests as a check. I mean, end-to-end tests with the network involved are notoriously painful to write and flaky. Yes, they're flaky. They make crappy checks. If you go look at the error message, you might learn something, so maybe there's some exploratory value. But mostly they're often more work than they're worth. And then because there's so much work, we only automate the happy path, which gets tested all the time anyway, especially in production. You're going to find out if you broke that. It's the weird error cases that are better to automate tests. But even then, automate this part. Automate the creation of users so that you can get to the meaningful stuff, which is the exploratory testing.
Yeah, and do this and automate it in a way that you can access it not just from your tests, but also just like at the REPL or on staging when you need to quickly set up a scenario. Every little piece of friction you file off of this process is going to pay off like tenfold.
Because it gets you to the exploratory testing, which is really meaningful, where you get to click around your system and find out what really happens.
Yes.
And experience the user experience.
Yeah, yeah, it's so much easier to do this. Oops. Yeah. It's so much easier to do this when you can set up scenarios quickly.
Yeah. Okay. And then once you have an application, you need to deploy it and work on it, or not even to deployment yet. So do use your checks in continuous integration, your fast checks, your ones that actually work in a laboratory, like your unit tests in a controlled environment, not the slow end-to-end tests. Don't wait for those all day.
No.
And then you get to the larger scale.
So the larger scale, now we have the app in production.
Yay, now it's on your team, providing valued capabilities. Yes, so use continuous deployment. And then when you have continuous deployment, the idea is that you can get it into production while it's still in your head. And so if there's a problem, you know right where to look. And then you can find out what really happens when people use it. It's hard to achieve, but when you can achieve it, it's really satisfying to be like, yeah, I did the thing. But watch out that you don't make this loop really hard with asynchronous blocking pull request reviews. Because if I'm waiting days for someone to review my code before I can get it in prod.
Or synchronous blocking code review.
Synchronous blocking. Synchronous is fine because it's fast. Asynchronous is the problem.
Oh, okay. I think of asynchronous as like you can get it into production while you're
No,
reviewing
that's
it.
non-blocking.
Oh,
so
right.
if you're non-blocking, you're fine. Yes, by all means, review my code, but don't make me start something new. Don't start something new. Go find another PR to review or something. Try to keep part of your head in the space until you get it into production. It's really hard.
Yeah.
So I really hate these. Just pair people, at least pair on the review. It gets two eyes on the code with shared context. It's so much better, and it doesn't break your feedback loop.
Yeah, fun fact, these blocking PR reviews were created for zero trust environments, and if your team is a zero trust environment, that's kind of a problem.
Yes, yes. Okay, the other problem that you might have is if your feedback loop from production involves enough customers hitting a bug and caring enough that some of them call customer service, and then enough of them do that the problem filters up to a project manager who eventually sends you a ticket that gets dumped into the backlog. If your production feedback loop is mostly through Jira, that's a problem. I wouldn't, it's stretching to call that a feedback loop. It's really stretching.
Yeah, and we can do some things to mitigate this.
Such as distributed tracing. Distributed tracing can help in local testing. It helps a lot in end-to-end testing. But in production is where it really especially shines because you can find out, would you click again? Yeah. You can find out what really happens. So this is Honeycomb. And in Honeycomb, I can go and I can look at what's happening in production. In this case, I'm like, why are those so slow? What's different about the slow ones? And then I'm like, okay, let's look at that field. Now let's run a different query. Now let's look at a trace and see what's so slow. And let's look at its field and what's the database statement that it's running over and over and over again. Now, okay, I did speed this up by 3x because I didn't want to take forever. But the pacing here in the queries is conversational. You're able to ask new questions, get enough of an answer to be like, well, that's interesting, let's look at that, and then ask another question. Avdi, you called this running experiments on the past.
On the past, yeah.
Yeah, because I can't it's not appropriate to run experiments in production at the small talk pace of every few seconds as soon as I can change the code. That's still going to be like an hour. You know, an hour is great for getting the code to production, but for finding out what happened, for investigating, and seeking out new questions to ask those things we didn't know we needed to know.
Yeah.
Like in this case, the discount code is messing it up, and we did not expect that. That we can get from a great tool that gives us that kind of feedback loop. So you've kind of got two loops there. You've got the loop of getting it into production. Yes, make that fast, but an hour is fantastic, really, for that kind of feedback loop, and most of a day is probably acceptable. But then when you're digging around, that we can make conversational. And, what's next? Is it feature flags? Yes, yeah. And in order to do that, you need feature flags. Feature flags say, okay, this code is in production, but it's not actually going to run. There's a big if statement. It's only going to be run when somebody turns it on, and for the customers for whom they turn it on. In order to be able to deploy your work every hour or every day, you need to decouple your production feedback loop from marketing's feedback loop of releasing a big new feature and making all their fanfare and what they need to do. Feature flags do that. They let you turn the feature on. Here's a count of things with page loads with the feature on. It's on just for me. It's on internally. Okay, it's on for a small set of customers. We can gradually release a feature, but the deploys are happening all day. Those tall things are deploys. The deploys are at a different speed from feature release, and that's really important because when you get to release a feature and you're talking about marketing and there are campaign things and there are press releases, this is not an hourly thing. This is not something you can iterate on every week. Your marketing message needs they need 3 months to find out whether something lands and attracted customers, and this is slow. So I don't want to work at that pace. I'm glad somebody does. The marketing team is super important because if nobody uses my stuff, I might as well not write it. And they make those connections. But we have to decouple that pace. So
speaking of pace, I think we have to
critical.
We have to
right.
Pace up.
Oh yeah, we do.
Here, so
okay.
We're going to burn through product team level here. A few ways you can tighten your loops here. Your customer support people.
Don't make them go to Jira.
Don't make your customer support people know things about how people use your system.
You
that
don't
you
want all of them pinging
imagine.
you in Slack, but you do want one or two.
Make a friend in customer support. This tightens a loop that you need to tighten.
And also there. Oh, can I have that slide a bit? Yeah, they're fun people. This is Honeycomb's real customer support team.
Yeah, they're great. They're great. Similarly, if you're in a situation where you've got a sales selling a new feature that you're developing,
We don't do that.
you know, that relationship can go one of two ways, and it usually doesn't go the good way. You don't want them having to fight their way through Jira again to get...
To tell you what matters, to prospects, what people are begging for.
Yeah. Make a friend.
Also, they're really good to have a beer with.
Yeah.
They usually pick up the tab. And we
then,
just get this
yeah.
one.
So, okay. At this point, we're getting really wide, and this is where we hit a kind of a transition, because everything we've talked about so far is stuff that you can kind of do for yourself. But at some point, you hit the level above your pay grade where it's really your job to enable these kinds of virtuous feedback loops for people higher up in the
Until you're a
business.
staff or principal engineer, you may not speak business. But somebody does enable them to build the business cases they need to.
Yeah.
In a spreadsheet.
Yeah. Yeah. So one of our tips here is when business asks you to please create this report, it is your job to push back and say, actually, I will give you CSV, and you can create any report you want to, and you can have that kind of REPL experience on the data that you need to. And a lot of times they'll be like, oh, you can do that? That's great.
And people love spreadsheets because they are a REPL.
They are
They
a REPL.
are all the hot reload. And Excel is the most popular programming language in the world.
It is.
Yes, it is a programming language. And this is fantastic. Let people explore, change a formula, see the graph change. Wonderful.
It's great. One of my pet peeves, I cannot tell you how many companies I've consulted for where like any change to the website copy, any change to pricing, any change to how we bundle things or doing a collaboration with another company, we want to introduce a copywriter into our system. All of those changes somehow get bottlenecked on development because development controls the company's website. Stop doing this. It is a solved problem. Remember auto manual. Automate the parts that you know are going to repeat. Your business people don't need to be blocking on you for stuff that you can manage by throwing up a WordPress instance, and you don't need to be interrupted in like the secret sauce by these annoying little website fixes. And that's all I'll say about that. Today. Finally, your business people are using business metrics to make decisions.
And they have their tools.
They have their tools that
And
they
their
like.
tools are good. Don't write their tools for them.
Do not.
But do support their use of their tools. So export data into Mode. Send events to Amplitude or Intercom or wherever your business people want to see what's going on. Your software has the power to say what happened in the world and make it communicate to your analysts and your marketing people.
Yeah.
And all of the BI and design and data engineers and everyone who is trying to understand the business. Our job is to support the tools that they are already using that let them explore, not to make custom screens for them.
So, seek exploratory feedback loops that are safe, automanual, explorimental, and conversational.
Yeah.
Ultimately,
Create this experience for yourself and support it for others.
Yeah, ultimately what we're talking about is, you know, don't just chase answers, chase new questions.
That's where the real insights come from. That's where you get the, ooh, why didn't the bacteria grow in this petri dish? New questions are valuable in a way that just answers aren't, because they say something about who we've become. They're how we grow as people.
Yeah. So that's it. We are, you can find references, and we'll stick the slides up at this URL here. I have to put in a tiny pitch for, like, this is my day job is I have this site called Graceful Dev where I have lots and lots of courses for developers. And yeah, thank you.